please come to the platform and please be seated. Yeah, welcome.
Thank you.
Okay. The pollution is becoming more and more serious, and many contaminants emerged. We do not know how many will come soon. So discussing emerging contamination and finding possible solutions are quite important. Previous role as the Dean of Faculty at the IIT Delhi, he holds the esteemed position of a Petrotech Chair Professor. Specifically expertise and an impressive high index of 75 and an I-10 index of 266. That's quite impressive. Additionally, he holds numerous patents and has successfully completed over 50 high-impact projects and consultancies were worth more than 1.02 billion. Distinguished Speaker Award, Herdela Award by Indian Institute of Chemical Engineering. There are a lot of awards from Professor Pant. And yeah. There are a lot of
for me. First of all, I would like to thank the organizers, especially Earth in a better way, or for generating the novel energy sources, novel water, because the basic challenges when you see in the country or the globe are food, energy, and water. And this nexus is to be resolved in an allied way. That's very important. And this is what is happening at present, that all these emerging contaminants which are coming into the water are creating the lot of damage to the entire universe, and we need again to find out the solution for all this. So whether it is industrial discharge, agricultural runoff, and the urban wastewater, we are making our entire globe, when we say, right, polluted because of this. And this is where you see that how does it go, right? It is because of the migration, it is because of the diffusion, it is because of the air contaminants, and all these things are affecting what you talk about the entire universe. And this is the key categories what you see of emerging contaminants: pharmaceuticals, all antibiotics, hormones, painkillers, then personal care products and cosmetics, again, sunscreens, lotions, hair dyes, parabens are coming up in a big way, right? Which are nothing but all these kind of, right, the chemicals which are used in, and these are alkylated phenol compounds, different kind of, right? If you look at the chemistry, that is much more complicated for this. And the microplastic is again a challenge. So up to 1,000 microns, these kind of plastics are going into the soil, into the water, and into the air, so creating the problem. Industrial chemicals like what we call perfluoroalkylated substances, PFAS, flame retardants, and agrochemicals like pesticides. All these are creating the problem and disturbing the entire ecological system. And this is again, right, microplastic. All of you know, the 27 kg of the plastic was found from the stomach of a dead whale. This is what we read several times in the newspapers, right? And this is what's happening, that the plastics, right, which is being used without any understanding, that is the concept of circular economy, that how can we ban the plastic, or how can we avoid these single use plastics. I think that is again, the industries have to give a thought. All academicians, research scholars, and the government policies should come in order to curtail this kind of, right, issues. And this is where the microplastics is again creating another threat to the society, and that is again a big challenge for the future. We need to find out the solution for this problem also. So you see, I have just to say, if you look at the repetition, the pharmaceutical water treatment is required, right? Industry mining, again, this is a big challenge. The water which is coming from the mining areas, that's again a problem. Agriculture areas, household products, all these are the challenges. And when it is treated, when you talk about the emerging contaminants, which are shown in the middle part, and that is all what I have talked in terms of antibiotics, personal care products, all industrial mining, right, leachates, and microplastic, pathogens, and antibiotics. And this is where we need to find out the extreme right, that how can we protect, right, our earth or protect our water bodies from these kind of contaminants. So it means the first thing is that the charity should be started at home. At home, household, right, we have to train our young kids, young generations, how the water is precious, how much water is being used, and how much it is being wasted. That is also, we have to train them, our young generation, that water is precious, we have to save it, and all these kind of contaminants which are being used by different, sometimes because of ignorance, we should train the society also. So that is also very important, that how can we communicate the message to the society, how can you communicate the message to the persons who are not able to approach these kind of conferences or seminars. That is also our duty, that we should train them, we should give them the value. You see the contaminated, right, which are talking, the chemicals, the structures, and you have to find out the solution by understanding the chemistry of these kind of products. So all these, what you see, the methyl paraben, ethyl paraben, propyl paraben, these all are alkylated compounds, you see that, right? All the phthalates are there, right? All the phenolic compounds are there, pesticides are there, synthetic. And the guidelines which have been given for all these kind of compounds, right? 8 microgram per liter, which is for fresh and the drinking water, that is the WHO guidelines. And this is where I think all of us have to work. And this is where you have to understand the chemistry and then find out the solutions, that how the water which is contaminated because of these parabens can be made potable. So this is where we talk one Earth, one family, one solution, so entire universe is one, and we have to talk in terms of the, right, what you talk from education, from research, so invest in research, so that is again a fund development, right, validation of different kind of, when we talk nature-based remediation. You see that, right, in the past, it was the nature, right, it was the kind of silver utensils which were being used, and that was a kind of antimicrobial, antifungal, these kind of metals were already being used. Right? And the nature is phytoremediation, what you call microorganisms are there in the water. Sometimes they are able to take care of themselves. That's also where we talk about the nature-based remediation. And I think the research should be promoted in these areas, which is a kind of NBR technology. The partnership is required, not only within the small group, but a big group should come. Multinationals, right, should come who are working in different areas. And that is one of the ways when we talk about safeguard water resources by scaling nature's own solution today. And that is where the nature-based solutions we have to propagate. Instead of utilizing the kind of chemicals for the treatment of waters, we have to find out the way that all these plant-based materials can be used for the water treatment, and that would be the solution for the future. So all of you know about this nature self-cleaning process, right? This is a kind of circular economy concept which we talk, right? So biodegradation, microbes-based remediation, dilution and dispersion, absorption-based treatment, so phytoremediation, all these, right? Chemical transformation. So these are the ways, right, where the biodegradation process can be made effective, and this can be used for the treatment of all these kind of, right, the challenges, the wastage which I have shown, that can be used by using the concept of nature self-cleaning approach. And this is just a case study what you see, right? This is being done in the globe, right, entirely, that this is just the contaminated area in the West Bengal of India, which is contaminated with lead. And that time, this kind of, right, the soil lead, which was more than 100 milligram per kg. And then this phytoremediation technique was used, where this plant was grown, which is named as a kind of lentil, you call it, or this is a, right, mustard type, right, mustard, which is something like, if you call biologically, Brassica junecia. So this is the plant, and which grows within 3 to 6 months. So that is the life of this plant. And this captures the lead materials, right? So this is where the same thing is being studied for chrome in the tannery, nearby tannery. The chromium removal can also be done by this approach. And similarly, these kind of algae biomass, which can capture arsenic, fluoride from the water, that is also, and from the mining area, right, in Germany, a lot of this kind of work has been done in the past, where some algae were cultivated which captured the arsenic from the water. So I think these are the nature-based, right, processes, and we should use this kind of, right, the process scientifically validate it and find out the ways that how it can be helpful for the, right, treatment of the water. So this is one of the ways. I was just thinking in that way, that bio-based adsorbent, right? Because plenty of biomass is available, algae biomass is available. You can convert into as an adsorbent. You have to use your knowledge of science and engineering and convert this into the different kind of products which are derived from the biomass-based product. So that is, you see, activated carbon, then low-cost, non-conventional adsorbent, the nanomaterials, composite materials, and now how to synthesize these things are very, very important. And for that, you need to find out the solution by making a team, and then this can be used for treatment of all kind of water. So this is just one approach that it can be done. You have the biomass, you convert it into some kind of carbon-based materials by whatever the method, right? There are different methods, right? Some pyrolysis used, some used some acid treatment, and directly these plant and leafy biomass can be used for this purpose. But at the end, you have to add some macro, right? What you call antibacterial, antifungal. So silver is well known, but copper can also be used. Copper is also well known. Zinc, copper, zinc combinations can also be used. And that is where you have to understand the physics and chemistry of these kind of materials and find out the solution. So this is what, right, the graphenes are coming up in a big way. Reduced graphene oxides are coming up in a big way. carbon nanotubes, and these all can be derived from the agricultural-based water. And I think this is the structures and all these things are very important. And how can you impregnate some metals to that, which will make this, right, the bonding, maybe pi-pi bonding, maybe some kind of adsorption-based, right, chemical adsorption, chemical or physical adsorption. So that thing can be understood by doing all these kind of, right, carbon nanotube, porous aerosols, carbon aerosols, which can be derived from the biomass materials. And these are very lightweight materials. And these can be used for even oil spillage. If you put it, just like this micro gel structure, they capture the oil from there. And that is, I think, the oil spillage problems can be solved. Microbes which are there, the parabens problem can be solved. And these kind of materials need to be designed and developed for the application for the treatment of the water. So this is what, right? At the same time, when I say that you develop the process, you have to understand the concept of sustainability, the concept of circular economy, because developing the nanoparticles, which may be effective because of its high surface area, but problem will be that what is the fate of nanoparticles on the water? So simultaneously, you have to find out that whether the process developed is sustainable or not. So sustainability is very important. Circular economy concept is very, very important. And we have to think on that way that is there any nanoparticle which are contaminating the groundwater? So one problem is solved, another problem may come. So we have to find out the solution for these kind of problems. So microplastic, all of you, as you talk, right, now these are coming up a big way, big challenge. We have to find out. And these adsorbents, the carbon-based adsorbents, are very effective for this kind of microplastic removal. So you have to just see that, right? The primary source, secondary source converted to microplastic, but we have to look at some kind of UV radiation, thermal radiation, oxidation, biofilm growth, and all these, if you coupled, right, that technologies which are already, right, at R&D levels, I think we need to take these technologies to the next level. And this is where I think when you talk about the small plastic nanoparticles, how these can be adsorbed and reused for some other process. So that is, again, I think, first thing is that you cut it at the source. Don't use plastics, right, which are single-use plastic. Train your, right, generation that the plastic bags, if they are keeping, keep it, right, and use it multiple times so that consumptions will reduce. So that is, right, one of the ways. But if this is happening, then we have to go for the solutions of these kind of challenges. So we are working on membrane-based process also, because adsorbent is one of the ways, and same adsorbent can be converted in the form of membranes. So cationic, anionic, these kind of membranes. And here you have a ability to recover the metals also, like arsenic, fluoride, chromium, or other heavy metals. The membrane can do that job. The principle of membrane is also, sometimes it is the molecular C mechanism, just a porosity. Sometimes it is based on ionic charge, which is called Donan principle. Sometimes it is your, right, permeability due to the chemical affinity, and sometimes it is biocatalytic degradation. So all these 1, 2, 3, 4 which you see, there also the R&D is required to work. And then we can find out whatever, whether it is microplastic, bacteria, or it is a heavy metal, which is charged pharmaceuticals, or hydrophobic pesticides, or biodegradable organisms. So everything. So you can avoid your ozonization, hydrogen peroxide, or advanced oxidation process, and you can go with this kind of techniques. And this is also being used for battery synthesis nowadays, graphite anode layers, cathode layers, and these are also examples for this also. So the same process can be used for the battery waste also, right? So this is what you see, that the functional membrane development and, right, emerging contaminant remediation, where membrane can play a big role, and these membranes are derived from the activated charcoal, which is coming from the biomass. So nature-based technique. And this is a kind of R&D which is being done, right, you talk in terms of the endocrine, right, deficient, that is the kind of the, right, your body's, right, organs are being damaged. So we can remove those kind of parabens, right, or pharmaceutical cosmetic products by using this hydrophobic approach for this kind of, right, and you can have different kind of the combinations of these kind of functional groups you can attach on this membrane, and just little bit the chemistry and engineering combinations can work much better when you talk about all this. So this is where, right, the when you talk about demonstrated state-of-the-art removal of novel materials, so our group is working on this now, on these different kind of the chemical organic framework, metal organic framework, where this kind of active metals can be at one of the centers, and this can be effective for the treatment of this kind of waste. So a lot of work is required in this direction. So that is, right, electrochemical approach, and that is again, right, the membrane, and you can have the electrochemical principle, some cathode material, anode material, and your contaminants can be removed by this. So these are also at the infant stage, and this can also be used your rare earth extraction, because the critical minerals are playing a big role for the future. So how these metals can be recovered by using these kind of membranes, that's again very important, instead of removing the contaminant, but also work for the recovery of these kind of critical minerals, and that is one of the ways by working on this. So I think research is required in this way. So when you talk about the nature remediation, just to conclude these points, so you have to understand that the eco-friendly approach, right? Environment-friendly, because sustainability and circular economy, before going for the, because societal importance is very important. So your technology may be successful, but if it is not acceptable by the community at large, then there is no meaning of developing such technology. So we have to understand this eco-friendly approach, that use the natural process without introducing the harmful chemical. This is the need of the hour. We have to work for the society. That's very important, and that is our motto. So cost effective, of course, the business point of view, the cost is very important. Sustainability, very, very important, right? Circular economy, ecosystem, enhance biodiversity, that's more and more plants, more and more fungi, and microbes, these improve the soil structure, that should be promoted. Then low disturbance, so minimal soil excavation, preserve the landscape integrity, all these things, and societal awareness, public awareness, that green and visually pleasing, so that is our, and this is what you see the bottom-top approach, right? We have to follow something like ecological restoration, and that is the need of our for water-based systems. So how to perceive all these things? There are a lot of challenges, right? This is just the kickoff, right, here. So when we talk about natural remediation, so we need to find out the new tools like artificial intelligence, data science, machine learning, right? How can we apply for selecting the different kind of adsorbent and their physicochemical properties. So that is also required. And this is, I think, younger researchers, they have to work in these areas. Genetic engineering is coming up in a big way. So that could be also, if you work on this genetic engineering, some robust microbial strains, right, these can be developed by using this. Then combined approach, because hybrid approach will be required. One technology may not be sufficient. A combination of these, using the greener energy approach, that is also very important. Climate resilience, I already talked on this, that breeding the remediation species tolerant to the extreme weather. So that's also very, very challenging. And all of us have to address these things. And urban application, so we talk about the, right, smart village, urbanization, all these things are very important, but to what extent, right, without disturbing the ecological system, how much sources of energy, sources of water, and how the crops can be cultivated effectively, because minimum energy consumption for maximum output, that should be our motive. When the irrigation is being done, the water consumption or conservation of water is very, very important. So how these drones or artificial intelligence can be connected to find out the novel ways of the irrigation or drip-based, right, technologies for water irrigation, that is also we have to develop so that water can be saved. And whatever rainwater harvesting, right, we talk a lot, right? So how these things can be conserved, right, where the scarcity water and then it can be used. So that is also our challenge. So I would like to stop here. Thank you very much for your patience here. But I would like to quote this work, that working with the nature ensures a cleaner and healthier future. And I think all of us have to adopt this. And that is, I think, the motive of this conference also. So thank you very much. So I think the questions we can have at the end, or if you have any question, I can answer. I hope the time is there. We have to manage the time. Yeah, okay. Let us have the organizer has just signed that I should ask the questions at the end. So let me start the panel discussion. So very good morning to all the panelists. And I'm happy that there are all 4 panelists are there. So already the introduction has been given, but just let me name it. Professor Thomas Bowen, Good morning, Professor Thomas Bovin. We have Professor Shiv Kumar. Good morning, Professor Shiv Kumar. We have Professor Hashina Moore. Good morning, Professor Hashina. And Professor Olga Makareva. Good morning. So, audience, I have been given 3 minutes per panelist, and the theme is on this, the topic which I have discussed. And idea is that how can the ideas to ideas and ideas to innovation and innovation to investment, that's always when we talk about as an academician, as a researcher, and when we talk about the startups also, that's what the very, very important, that how it can be taken to the entrepreneurship skill level. So my questions are related to those things, and first I would like to ask the question from Professor Thomas. Based on this, emerging contaminants, which you also feel that, there are a lot of challenges to be addressed. So, according to you, I will ask a very general question for the audience also in that way. What are the most pressing issues that emerging contaminants problem pose for the society all around the globe?
There we go, technologically challenged. Thank you for your question, a wonderful presentation. You have highlighted many very important issues, natural solutions. I think this is something we need to strongly consider, because there's a lot of examples. If you go back in history, people for thousands of years have been using natural remediation systems. I'm thinking people who live next to rivers have dug wells for thousands of years, drawing water from the river to those wells, in the process taking advantage of naturally occurring cleanup solutions, filtration, straining, microbiological predation, and whatnot. This is now known as riverbank filtration technology. Practice in India, practice in the US, practice in Europe for hundreds of years, but it goes back thousands of years, because our ancestors already knew that there are natural solutions that Mother Nature has designed to fight bacteriological contamination, heavy metal contact. These are all problems that have been around for thousands of years, nothing new. What's new today is emerging contaminants. Many of these compounds, 99% are man-made, pharmaceuticals. This frightens me, I think, the most, because pharmaceuticals, we basically consuming somebody else's medication via polluted water. And think about antimicrobial compounds or psychopharmaca. These are very, very potent chemicals that the doctor prescribes for a very specific purpose. But if you consume it with your drinking water, you are exposed to these compounds, and they do a number on your system, on your body, on your brain, on your organs. So I would like to end with saying that for me, we are at the moment in history that reminds me, and I'm old enough to say that, to Rachel Carson's Silent Spring, 1962, a long time ago. But that was a very crucial turning point in how we perceive the environment, how we, Rachel Carson basically made the point that DDT, a pesticide, is killing the birds, is silencing Mother Nature, is doing bad things to nature. That was 60 years ago. We are now facing a similar issue with these pharmaceuticals and personal care products, and we have to be very careful to make sure that we're not falling in the trap of not addressing these problems. Thank you.
Yeah, thank you, Professor Thomas. I think there's a very pertinent point when we talk about the use of pharmaceuticals and the industries and the end users, there should be a proper balance when we use these kind of, and doctors also have to play a big role, when they prescribe these kind of, medicines also. Thank you very much. So my next question is from Professor Shiv Kumar. So, Professor Shiv Kumar, what do you think, in terms of the emerging contaminants impact, on soil, plant, water, and microbes, which lead to the loss of biodiversity, and may also reduce the crop productivity?
Thank you, sir. It's a very good presentation. First of all, I should appreciate the way in which he covered the topic of emerging contaminants. I think he didn't leave anything for us to brief on that. But being a panelist, I should emphasize some of the important points pertaining to the question. And number one is the contaminants are everywhere. The air we breathe, the soil we walk, and the water we drink. Everywhere contaminants are there. So the only living system that are present in all the sphere is the microbes. So microbes are here to protect you, protect the environment, protect the ecosystem. So you have to consider the ecosystem as a whole, because now everybody talks about One Health. So One Health means it is not just about the plant, it is not just about the food that we eat. So we have to think about the animals that are eating the plant greens and the plant waste. And we have to think about the environment where we live, lots of contaminants. And we have to think about the human being, which we are eating the food which carries the contaminants. So when we think about the whole system, the One Health is very, very important. So when we talk about One Health, which is a transdisciplinary, so where we have to think of what is the contaminants that is being released by the animal in the form of excreta. What are the contaminants that are being released by the plants, plant exudates? And then what are the contaminants that are being released by the industry and wastewater? So many things are there. So we have to consider as a whole. And I would like to suggest three important strategies. One is you have to identify what is the contaminant. And then you have to track where it goes from the starting point to the end point. That is, fate and transport of these contaminants is very, very important. And the factors and the process associated with this transport is also very important. And number two is how the plants take up this nutrient, take up these contaminants. Because plants are there, plants are associated with full of microbes, starting from the soil to the seed, everywhere microbes are there. So they facilitate the plant to take up the contaminants, and then they process it, they metabolize, and then they get decontaminated, detoxified. So this is a process which you have to track around. And then the last strategy that I would like to suggest is the mitigation. So you have to develop a sound mitigation strategy. I think our chair has given lots of strategies, starting from natural remediation, accelerated remediation, so many things he has spoke. So the third strategy is mitigation. If you have a sound mitigation strategies, starting from the basic technology to the advanced technology like nano particles, nano methods, or anything can be used. And if you integrate one or more methods together, definitely we can get rid of the contaminants. And then the final point that I would like to say is, sir has completed with the nature. So nature is full of resources. So if you conserve nature, nature will definitely protect you, protect your ecosystem. Thank you.
Thank you, Professor Siva. I think you have given the complete cradle to cradle approach, right, for treatment of these kind of emerging contaminants. Thank you very much. I will come back to, right, I will go to Professor Olga now. Right, Professor Olga, according to you, right, because you had been working on this mining and all these things, right? So mining industry is a source of emerging contaminants when we talk, and connected with the sustainable development, right? So how will you make a proper balance, because mining is also equally important, right, for getting the right resources?
Yeah, thank you very much. First of all, I would like to say that I'm honored to sit in front of such distinguished scientists, and thank you very much for inviting me here. So I tell you my story. All my life I lived in St. Petersburg. It's a big city with good waste treatment, clean water, and etc. So good conditions for living. And 5 years ago I moved to far east of Russia, and now I live in the region which is the first region in gold mining in Russia. So, and gold mining is done there by an open method. So the river valleys are excavated and digged up, and after this process was already for 70 years there. And when you come from a nice city and you see this nature, which is heavily disturbed, and moreover, it doesn't recover because of the climate conditions, vegetation conditions, then you realize this problem of contamination and nature disturbance. And here I would like to bring up the ethical issue, actually, because at the moment, yes, we have, my opinion is that we have the methods to clean our waste, to preserve the nature, but it's easier to bring our industry into some inhabited regions, or even worse, to some developing countries, because we know that heavy mining, in general, mining industry is now developed, has moved from developed countries to developing countries, and it's where we have the many spots of this contamination. And even in Russia, we have disbalance in the region. So the consumers of this mining industry, they live in better conditions than the people which stay in those regions of mining. So I think that developing the science and the methods to somehow to deal with these problems, we shouldn't forget about some ethic problems. And even I think that those ethic problems, they're even more important than the technology, which is already developed in a very high level. And I'm sure we can, if we use it in a full, we can solve all our problems. So thank you very much.
Yeah, thank you, Professor Olga. I think this is a very, very important and pertinent, point which you have raised, because the minings, how to do it effectively, and then, what kind of phytoremediation, I think that would be one of the ways where, nearby area, the plantation can be done, for solving this. So, I'll come to Professor Hashina now, yesterday you delivered a talk on arsenic, fluoride, and, very, very contaminants, certain points you have raised. So, with your expertise, what are the major potential sources, type and pathways of human body which affect because of this emerging contaminant? I think endocrines and all these things, you would be able to answer that. Yeah.
Thank you very much, Chair. Please allow me to introduce myself for those who don't know me. I'm a professor at the University of Johannesburg, and I hold a chair in UNESCO, and I'm the president of the International Union of Geological Science. Thank you very much, Professor, for the question. We heard from your excellent presentation about the emerging contaminants from anthropogenic sources, which are man-made. But behind that, there is also nature. I would like to illustrate with an example of the sources of contaminant from a natural perspective, to which we add another layer of human contaminant. In many years back, people practice what we call geophagia. I'm sure some of you know about it. It's quite common in Asia and in Africa, where people eat clay or soil or rocks. This is a very, there are very different reasons for this, including cultural or tradition, and people use it for health, especially pregnant women, because they lose a lot of blood, iron, so they think this soil will bring back or cure anemia. So during those times, it was like a medicine for people. However, in recent years, what happens is there is another layer of issue that's superimposed to this, because most of the people who are consuming this material, they live in rural areas and sometimes near mining. What means is that when you live near a mine, you add a layer of contaminants from the mining environment into this material. And these people are not aware of the danger, and they consume this material So in addition to the original issue from the nature, the contaminants that are issued from the nature itself, now we have another layer of a source of contaminant from the mining practice. And through this, we cause a number of health issues, not just to the mothers, but to the babies. And then we wonder, why do we have all these children born with deformities and health issues? And when we look at, as I said yesterday, we look at the health reports from the World Health Organization, a number of non-communicable diseases are just going up and up and up. So there is growing evidence that man-made contaminants, the emerging contaminants, are endangering more our societies and causing more and more health. So if we don't refrain from these issues, we cannot live in a safe environment. So it is up to us to, as you said, Prof, that we need to find solutions to this, at least the man-made issues, because natural issues sometimes difficult to fix them, but at least if we refrain from adding another layer from human-made pollutant, that might help at least to decrease the impact on the health of the population. Thank you very much.
Thank you, Professor Krishna, for explaining the medical complete process on these potential sources and how they impact. Since we have a paucity of time, so I'll go to the second round of question, and I would like to find the answer in 1 minute. So that's a little bit challenge for all of you. So let me go back to Professor Thomas. So Professor Thomas, what do you think, what are the options, right, available, right, which can be used to remediate these kind of emerging contaminants?
Yeah, that's a broad topic. It takes way more than 1 minute. But first and foremost, it's our young students who have to tackle this problem with the guidance of our more experienced colleagues. But this problem will be around for a generation, if not longer. And there are so many different chemical compounds. You have shown just a few examples. A large group of very diverse chemicals. It's very difficult to find one silver bullet to treat all these compounds. So that means we have to study classes of chemicals, classes of pharmaceuticals and whatnot, and find solutions that can be used to treat these specific groups. And some of these solutions are natural, some of them are way more complicated, chemically based, photolysis, reaction, oxidation, and whatnot. So I guess the challenge for our students is to pick and choose very carefully where they want to invest their intellectual capacities and find solutions to address these many problems. Thank you.
Thank you. So I'll come to Professor Siva, being an agriculture engineer. So what do you think that microbes and metabolites can be helpful to remediate these kind of emerging contaminants?
Thank you, sir. Well, I said in the beginning, microbes are everywhere. So these microbes produce metabolites, for example, enzymes, oxidative enzymes, hydrolytic enzymes, any kind of enzymes. So they are known for changing the biochemistry of the chemical contaminants into less toxic. So if they are converted into less toxic, we have to be very careful that it is not carried away by another ecosystem. So make it non-toxic. So that process can be mediated by the microbe-derived metabolites, number one. Number two is that there are some microorganisms which acts as a carrier. Say, for example, the microplastics. Microplastics acts as a carrier to transport the antimicrobial resistant bacteria and antimicrobial resistant genes. And when you use these microplastics as a carrier, it is possible to identify and use microorganisms as an indicator to locate these contaminants in the water bodies are notorious one. So that is also possible with the microorganisms. Thank you.
Thank you, thank you. So, Professor Olga, just over to you, because the mining industry is right, and a lot of work has been done by your team also. So, what do you think that remote sensing technologies, right, which are upcoming, and how will it be right helpful to monitor and prevent right these kind of contaminants from the industry, mining industry?
Yeah, I was thinking to talk about remote sensing, but now I thought that much more important issue is to bring this knowledge to the government and make it use it, because as your minister, the Minister of Science yesterday told that government which doesn't listen to science doesn't have future. So yes, we have developed very much the remote sensing methodology and how to monitor the contamination and to stop it. But the problem is that the government doesn't want to use it. We had several projects which was funded by a big gold mining company, and we thought it was environmentally friendly and trying to develop these issues, this knowledge. But when we proposed them to use remote sensing for controlling and monitoring the environmental impact, they stopped funding us. So probably it's important not only to develop the technology, but to develop our skills to bring this to the to people who take the decisions.
Yeah,
Thank
these
you.
are the big challenge, getting the funds and all these, but yeah, thank you. So, Professor Hasina, because you had been, right, recently awarded the UNESCO Chair in Medical Geology, right, in Africa. That's a very prestigious award. So, because of your experience, right, how to prevent, right, when we talk about the health issues, right, because of these emerging contaminants, can you just very briefly throw some light on that?
Thank you, Prof. I try. As Prof. Thomas said, it's a very large field, but I try to be brief. First of all, I think we need to learn to treat the cause of the problems, not the symptoms. And this is the big challenge with our healthcare system. We tend to just treat the symptoms and don't look for the causes. Yeah. As a matter of fact, then if we don't treat the cause, if we don't look for the cause of a disease, we will never end the disease. So it is important to deal with the issue of the source. And then, of course, another aspect is to encourage multidisciplinary, cross-disciplinary research, because we cannot solve a problem with one single discipline. We have to, it's a puzzle. If one piece of the puzzle is missing, then the picture is not clear. So we need to put our efforts together. And finally, I think it's very important to train our students to understand their environment, because this young generation are the ambassadors of the discipline of multidisciplinary studies, and they can, if they understand their environment, they can help their communities. As you mentioned earlier, warning is a very important. If the communities know what is around them, what is the danger, they can learn to live with the danger without being harmed. So this is just in brief, yeah, there are many other aspects, but time is limited. Thank you very much.
Thank you. So thank you all the panelists, and now it is open for discussion. So since we are in short of time, but we can keep 5 minutes, right, with the permission of the coordinator. So 3-4 questions can be taken. So please target whom you are asking the question, and be brief in the question also, so that we can also be brief in our answer.
Yeah, a great technically session and technically rich and a vibrant session for the day too. My question is directly to Professor Thomas Bowing. You mentioned that in the hundreds of thousands years ago we were using this river bank filtration process, But that time, the load of contamination in our soil water sources was not so heavy, but now because of all this technological advancement and population growth and all, so the load of contaminants is also very high as well as it is very much variable. So indeed, we have to take some precautions by using such type of the technology. So what is your take on, or you can say general suggestion to go for such type of this, nature-based remediation, especially for groundwater contamination and cleaning? Yeah, thank you.
You're bringing up a very good point. The contaminant loads today are much more massive than 100, 200 years ago, or 1,000 years ago. So riverbank filtration can still be useful in areas where the loads are lower. So in India, for example, we're working in rural villages, in Karnataka mostly, where contaminant loads are high, but not as high as in urban areas. In urban areas, riverbank filtration, natural processes are basically no longer working because there's just too much and too many contaminants, meaning these natural treatment systems are completely overwhelmed. But if you go into the more rural areas, then the loads go down and these natural systems still work. So I look at riverbank filtration as a transition technology to the time when rural villages get wastewater treatment plants or drinking water treatment plants. In the meantime, they can rely on natural systems. But it's very much case specific, absolutely. Thank you for your question.
Thank you. Yeah, that's another question is from this side.
So good morning. Very good presentations, and Dr. Keshi Pant and other panelists has discussed very lot. So my question is directly to the Dr. Pant. So the population growth and industry development, it is inevitable in our country, especially in the globe level, which leads to the contaminations in all the natural resources. But lot of remediations through biological system like microbes and plants is being done, which can be very well a good solutions for the organic contaminants. But in the case of inorganic contaminants like heavy metals, it's very difficult to, either we can, a short period of time, we can stabilize that. But how to remove those things? If it is in soil, it can be removed by phytoremediation or by microbial remediations. But again, it goes to another form. But how to ultimatum? So it's my question. And I have one suggestion on this. So research on this recycling of these heavy metal contaminants, it is not much extensive or intense, you can say. So this is my suggestion. Thank you, Doctor.
Yeah, thank you for your question and very pertinent point which you have raised. Because I told you the resource recovery is very, very important, right? When you talk about the heavy metals like chromium, arsenic, even when we talk about the lithium, right, from the battery waste. So, and now you see all the electronic waste materials like printed circuit boards, mobiles, right? 3.5 million tons per day, this kind of waste is coming, right? So the important thing is that's what I always talk on terms of resource recovery. So for these kind of, right, metals are very, very important. And when you see that critical minerals now, these are coming up in a big way because you have to manage with the available resources. So the materials, when this mobile is being written off, every metal of that should come back to the, right, again it should be refurbished. And that's what I think many countries, they have already adopted this. When you talk about the contaminants from the groundwater like arsenic fluorides, right, and the other chromium-based, right, and mining sources, I think these metals, when they reach to certain concentrations, they can be recovered, right? And then they can be reused in the process. Because all these are very, very costly, say chromium, cobalt, nickel, manganese. So these are to be recovered. So whether adsorbent, suitable adsorbent, you use it and then desorb it. So adsorption, desorption, that cycles can be used and these are designed, this can be done. Membrane, that's what I was taking the example of membrane because there the recovery is easier. So you can get all the metals to certain concentration and take it. So I think the research is being done. And societal awareness is very important when you talk about for these points because otherwise it will become a major threat. For that, these kind of, when they reach to certain concentration, like I was giving one example of arsenic, where one of the professors, I remember Brigod Das from Germany, they were working in the mining area, they cultivated these kind of plant materials, right? And using that concept, we use this phytoremediation concept in one of the areas where this chrome plating was being done. And then chromium was recovered by this metal. And when you convert this plant material into biomass to char, this chromium comes into the metal, and then you recover it. So those kind of things are to be done. Thank you. Yeah, one more question. I think we should, this is the last question, which will be answered by our panelists.
Yeah, thank you. This is very pertinent topic for nowadays. Actually, my question is regarding the peri-urban agriculture. Basically, in the populated cities, in many places, we found some agriculture around that city, and it is directly coming to the consumers, means very fastly. So in that case, can we have some suggestions, or can we put on light that which kind of crops we should grow in that regions and which should not be there? So that the consumption to the human can be avoided, or can be, we can put on light on that, sir.
Professor Siva, would you like to answer?
Thank you. I think it's a very good question. There are several plants available. Some reeds are available. If it is a water bodies, you can grow the reeds and then collect the reeds, and then that can be destroyed. As the professor said, this can be also recovered and then reused for various applications. And along with the reeds, you can also use microorganisms in the constructed wetland, so where you can introduce the wastewater and then get it recovered, decontaminated. So that is also possible.
Thank you. So let me close this session. And on behalf of the organizer, I thank all the panelists and Professor Hashina Mori, Professor Olga, Professor Shiv Kumar, and Professor Thomas. Thank you for joining this panel. And indeed, it's a pleasure to interact with all of you. Thank you very much.
Hello, colleagues. Yeah, small information. Colleagues, this afternoon, offers one of our Deputy Minister from Water and Sanitation is chairing the sessions. I hope this session was excellent. Same like that session also we are expecting. It should be very interesting. They have some protocol when the Minister is here. I would like to suggest all the delegates, participants should be here at least 5 minutes before. This is my kind request. Thank you. We are giving 10 minutes to move to your parallel sessions.
Hello. All right. Good morning, everyone. I think we might as well start. I can see the audience is a bit depleted, but it's my pleasure as a co-chair to introduce the chair of this session, Professor Hui from Chang'an University in Xi'an in China. And he will be telling us about the Yellow River Basin.
Yeah.
Would you like to take it from here?
Okay.
Thanks.
Good morning, ladies and gentlemen. My topic today is groundwater and its functions and effects in the Yellow River Basin, China. So this is my contents. First, a brief introduction. Yellow River, located in the northern China. It is the second largest river in China and the fifth longest river in the world. It spans across 3 major terraces of China with the lengths of 5.64 kilometers and a watershed area of 752,000 square meters. Yeah, as you can see from the figures, the Yellow River spans across 3 major terraces. The first terrace is Tibet, the highest continent on the earth. The second is the Lewis Plateau. The third one is North China Plain. Yeah, in this, the Yellow River, the average annual runoff is about 49 billion cubic meters every year, and this water is only about 2.5 of the water resources, total water resources in China. But the cultivated land in this area is about 17%, and about 120 million people lives in this basin. Yellow River is known as the Mother River of China. Chinese civilization was born here. However, scarce rainfall, intensive evaporation, fragile ecology, severe water shortage, and frequent droughts are the typical characteristics of the Yellow River Basin. So, how to use and manage groundwater in Yellow River Basin is a major challenge. So, the second part, I will talk the groundwater in Yellow River Basin. So, we'll calculate the volume, the water volume of groundwater in this basin. The groundwater in Yellow River Basin, so the geomorphology. The Yellow River Basin has a total of 66 types of geomorphic units, including plains, hills, mountains, plateaus, and floodplains, etc. The plain and the basin accounts for 63%, while the mountainous and the hilly areas account for 37% of the total area in this basin. The geology, the basin has a complex geological structure with clear lithological zoning in the upper, middle, and the lower reaches. As you can see in the tables, the rock types, different rock types, metamorphic rocks, sedimentary, magnetic, quaternary sediments, and water bodies. Yes, the different areas, the different proportions they occupy. The hydrogeology. There are 7 kinds of groundwater in this basin. In this basin, the water resources in the upper, middle, and lower are different. So the groundwater, yes, in the upper reaches, it's about half of the total. So we calculated what groundwater volume, groundwater storage in this basin. Yes, we collect a lot of boreholes and in the different plains. So the calculated groundwater storage in Yellow River Basin is 25.4 thousand billion cubic meters. So it's a very huge volume. All those basins, as you can see in the middle of this figure, account for 47. Plain areas about 48. Other areas only 5%. Ground storage Yellow River is about 518 times of the Yellow River's runoff. So the table shows in different plains and areas the volume, the volume and the area of the water. So all those basins accounts and the plain areas accounts more than 19% of the total. So let's compare the calculated results with the water volume on the continents. The annual precipitation in Yellow River Basin is about 375 billion cubic meters, and 13% of it converted to runoff, and about 10% converted to groundwater. By volume, groundwater accounts for 98.58% of all the water bodies in the basin. It's larger than the global volume proportion. Yeah, it's the global. It's groundwater only. The proportion is only 99.46%. So the third part, functions of groundwater. The groundwater is a stabilizer of ecosystem in the basin. It's the invisible lifeline of ecosystem. No groundwater, no ecology. Unreasonable groundwater depths will lead to ecological degradation. So the groundwater maintaining the wetland, supporting the terrestrial vegetation, maintaining soil ecosystem, maintaining biodiversity. So in the basin, we found the types and distribution of vegetation are closely related to groundwater depths. Groundwater-dependent ecosystem has become an important research frontier. So the second one is regulator of water resources. The large storage of groundwater in the basin provide a place and possibility for regulation of water resources, ensuring the basic stability of water resources in dry years. So from time scale, they will store excess water during wet season and release water during dry seasons to supplement water shortage. So from the spatial scale, about 40% of groundwater in the basin comes from littoral recharge in mountain areas, which makes groundwater also makes water resources interconnected. So if we say the river is the blood, so the groundwater, they can transport, yes, connect different water bodies. So, and the groundwater also balancing climate fluctuations, peak shaving, and valley filling of water resources is important. The third one is balancer of river flow. The sections that receive groundwater recharge accounts for 80 to 85% of the total length of Yellow River. 51% of the runoff in middle and upper reaches come from groundwater, which ensures relatively stable river flow. So the Yellow River can be divided into upper reaches, middle reaches, and the lower reaches. And the upper reaches with a length of 3,472 kilometers can be divided into two parts. The first part, the base flow index is more than 0.41, and in the second part, in the wet seasons, river replenishes groundwater, and during dry seasons, groundwater recharge river. And in the middle part of the river, the base flow index is about 0.4. And in the lower reaches, the river supplies groundwater. And groundwater is also the connector of precipitation and the river. To replenish river, precipitation must first infiltrate and transform into groundwater. Groundwater is a key link in its connection. Groundwater is also the substance exchanger and the energy flow which connects the surface water and the river water. Also, of course, groundwater is a water supplier for humans and animals. So the Yellow River flows 7 provinces in the northern China. So we have a statistics about the groundwater uses in the seven provinces of the Yellow River, and we also statistics is in the middle, upper, middle, and lower. So and the proportion of different reaches in the Yellow River is the middle part use more groundwater. And the groundwater is the booster of grain production. The Yellow River Basin is the main grain producing area in China, with irrigation areas accounting for nearly 13% of the country's total, and producing total production, and 13.4% of the country's grain. Groundwater accounts for about of the irrigation water use and ensures the country's security. So 3 super large irrigation areas is in this area, and 4 World Heritage Engineering heritage sites is also here. The effects of the groundwater in the basin. Here, I mainly mention the negative effects. The soil salinization. Irrigation infiltration leads to an increase in groundwater level, causing salt to accumulate on the surface, damaging soil structure and reducing quality of cultivated land. The total area of saline land in Ningxia Plain, which is in the middle part of the river, in Ningxia Plain and Hetao irrigation area in Mongolia is about this large, respectively, accounting for about 33 and 45% of the total. So the soil salinization in this area is also a very serious problem. Land dissertation. Land dissertation of land in the basin mainly concentrated in the middle and upper reaches with a proportion of 90 driven by climate change and human activities. The contribution rate of human activities to land dissertation is higher than that of climate change. They are in this sequence: the drawdown of groundwater level, dissertation of soil, decrease of soil quality, vegetation reduction, and finally the land dissertation. Deterioration of water quality. The unreasonable development of groundwater lead to the connection of inferior and good water. So resulting deterioration of water qualities in this area, the large area, many places we have not so good groundwater. If we do not develop in a good, reasonable way or scientific way, they will deteriorate the water quality. Geological disasters. The over-exploitation of groundwater has led to formation of deep depression funnel of groundwater surfaces, causing ground subsidence and fissures, and landslides caused by rising groundwater levels occurring in many places of the basin, which even damage cultural relics and historical sites. This is some of the problems caused by the geological disaster caused by the groundwater suppression. If you have ever been to the Xi'an, the wild goose pagoda is even leaned because of the obstructing of groundwater. So the last part, conclusion remarks. Not really a conclusion. This is only the Yellow River Basin has a huge groundwater storage. Its cyclic transformation is an important part of hydrological processes. Due to the differences in geological, geomorphological, and hydrogeological conditions, as well as anthropogenic influences, there are significant variations in the circulation of groundwater. At the same time, atmospheric precipitation, river water, lake water, reservoir water, and groundwater in the basin interweave and influence each other, forming a complex systems. In this system, groundwater plays a crucial role to deeply understand and accurately predict the hydrological processes of the watershed. In-depth research on groundwater is an unavoidable hurdle. So it's not an answer, but yeah, we've done a lot of research in this area, but we need more answers. This is the expedition we've done in the Yellow River Basin. So some photos. So that's all. Thank you for your attention. Thanks.
Thank you so much, Professor Hui, for a very interesting presentation. This was the opening presentation of the session, so it's allocated 25 minutes. So we've got about 3 minutes. We can take 2 or 3 questions. If no one else has a question, I can ask something. Would you tell us, you mentioned biodiversity, so there are important conservation areas in the Yellow River Basin. Would you be able to mention some of them and some of the specific ecological processes or species that are protected there?
Yeah, but yes, biodiversity is a very important part of the ecology. So because of the abstraction of groundwater, the soil becomes dry and dry. So the biological systems changes. So some even in some areas, the salt accumulated. So they change also the biodiversity. So yes, the unreasonable and unscientific development of groundwater in this area can cause a lot of problems. So we need to do much research. We need the answers how to reasonably use groundwater in this area. Thank you.
Thank you. One more question, please.
Sorry.
Microphone is coming.
Okay. So the headwaters of Yellow River are in the permafrost conditions. How does permafrost degradation impact groundwater storage and groundwater processes? Thank you.
Thank you. Yeah, in the Yellow River Basin, the upper part of the river is in the permafrost area, and with the climate change, the temperature increases. So the more and more frozen water, the ice becomes they melt and becomes water and becomes infiltrate into the soil and replenish the river. So we can observe, we can have the results, the runoff in the upper regions of the river becomes more and more in recent years. Thank you for your question.
Thanks, Professor Hui.
So,
yeah.
Today, the second. The second talk is by, Serban Proch. Yeah, his topic is, I think,
so we
thank
get
you, thank you.
second presentation?
Second presentation, so we can begin.
Do you have the...
Yeah.
Yeah. Thank you. Thanks so much. Thank you, Professor Hui. So my presentation is about measuring biodiversity across spatial scales. And it's not a hydrological presentation at all. In fact, please don't ask me any profound hydrological questions. This is not my background. It was placed in a hydrology session a bit by chance, but that being said, I am hoping that you will find it interesting, and especially some bits towards the end of the presentation, which I do think are quite relevant in a hydrological perspective. So I describe myself as a biogeographer, so I study the distribution of living organisms across the world, mostly across geographical scales, but also across finer scales. And for those of you who are less familiar with the conservation of biodiversity, I would like to mention a few basic facts. So when we conserve biodiversity and ecosystem function, we're basically preserving two separate things which are interrelated, but they're treated quite differently in conservation. So on the one hand, we're preserving areas, geographic areas, which become conservation areas. And on the other hand, we're preserving species. So if a species is viewed as being endangered, it becomes the target of conservation in itself, but it's a lot more meaningful to preserve entire areas, and then the species that live there are implicitly also preserved. So there is an area approach to conservation, which are prioritized on a global scale, and the map that you're seeing here is a map of the global biodiversity hotspots. And as you would know, there are more species close to the equator in ecosystems such as rainforest, tropical rainforest, coral reefs, and so on. And as we move towards the poles, we get fewer and fewer species. So most of the global biodiversity hotspots are located in the tropics. And then within these hotspots and also outside biodiversity hotspots, we can declare strict conservation areas like national parks. It depends at what level they are conserved. They can be national, they can be provincial, they can be local conservation areas. And then separately from these, we have the species approach, and on the right, you can see the classification of threatened species on different levels. So you get species that are already extinct and there's nothing we can do about them. Then there are species which are extinct in the wild, critically endangered, and so on. And we can put a protection, a legal protection on them, irrespective of whether they are in a protected area or not. So all of these are classic approaches to conservation. If you're looking at the years, the IUCN, which is the International Union for the Conservation of Nature, already came up with these categories of species in 1964, and practically nothing's been changed in that classification ever since. Biodiversity hotspots, the idea came up in 1988, and then the first set of biodiversity hotspots were described in 2000, and then in 2016 we have added a few of those. Now, the question is, are all species equal in the face of conservation? So we've got two different types of species that we can conserve. We can place special emphasis on them. On the one hand, it's species that have a great importance in maintaining ecosystem function, So in that context, we can talk about functional diversity, and then we can also place special emphasis on species that are more different from other species. So we call this phylogenetic diversity. So phylogenetic diversity is related to species diversity, but species that are less closely related to other species get greater emphasis. I'm just giving you some examples here. Things like a platypus. It has no close relatives, so it's more important from a conservation perspective than one of 600 species of gum trees which are quite closely related to one another. You get entire groups of organisms like the velvet worms, which are restricted to very specific areas like the tropical rainforest and then southern temperate rainforests. And in terms of functional diversity, you have groups like earthworms. So earthworms are broadly distributed across the globe. So you find them throughout tropical areas and in most temperate areas. But they're slow moving. So if you're looking at the map of Canada, the last glacial maximum at the top, you see practically all of Canada was under ice at the last glacial maximum. So plants and fast-moving animals have been quick to recolonize all of Canada following the melting of the ice cap. However, slow-moving things like earthworms did not. So most of Canada was naturally earthworm-free. So now if you're thinking of soil function, that's very different in the presence of earthworms and in the absence of earthworms. So it's an entire large group of organisms that was naturally absent from world's second largest country. So now if we're introducing earthworms there, which has been done inadvertently from other parts of the world, we're changing completely soil function. If you're looking at species richness, you're looking at phylogenetic diversity, and you're looking at functional diversity, you're going to see they're closely related. So for example, you've got maps of these three measures: species richness, functional diversity, phylogenetic diversity, across Europe in this case. And you can see there's a positive correlation between these variables. Nevertheless, if you plot species richness and phylogenetic diversity against one another, you can then map the residuals, and you can see certain parts of the world are overrepresented in terms of species richness, and other parts of the world are overrepresented in terms of phylogenetic diversity. This is an example from, well, the only paper I managed to get into Nature, and I don't know if I'll ever do that again, so I might as well mention it now. The map that you're seeing at the bottom, this is the Cape Floral region in South Africa. You can see that in the western parts of it, which you're seeing in blue, species richness is higher than you would expect from phylogenetic diversity. And in the eastern part of the Cape, you have higher phylogenetic diversity than you would expect from species richness. Now, all of this is in a static perspective. So we can measure species richness, phylogenetic diversity, functional diversity the way they are now. But we also need to understand how these variables might actually change with climate. And this sort of studies have been done all over the world. You can see studies in Europe, in China, in KwaZulu-Natal, in Mexico. All of them are basically doing the same thing. They're telling you, this is where this species lives now, and this is where it's likely to live in a changed, warmer climate. And as you add the distributions of species in the novel climate, you'll get a picture of how species richness and how phylogenetic diversity might change with climate change. But all of this is actually mapped at regional scale. And what I'm trying to point out here is that we need to find an intermediate scale to understand the preservation of biodiversity. So mapping things at the regional scale is useful, but it's insufficient. protecting species is useful, but it's insufficient. What we really should be looking at is small-scale ecosystems should be declared protected onto their own. So I've been looking for studies that actually look at how small-scale ecosystems might move with climate change. And the conclusion of such studies is invariably the same. We need to protect, if we want to protect species, it's insufficient to protect larger areas because ecosystems might completely shift out of that area. It's also insufficient to protect species because we need to protect the ecosystem that the species live in. So I found several studies that look at finer scale and how finer scale ecosystems might move with climate change. But somehow we're not getting a complete picture of how all of this will change with climate change. So I want to focus here, because I'm in a hydrology session, on the distribution of moist environments, because a whole lot of species and broader groups of organisms, basal plants like mosses, basal invertebrates, they all live in moist environments only. Life started in water, and it took lots of serial adaptations for life to move on to land. That means phylogenetic diversity is invariably higher in moist ecosystems compared to drier ecosystems. We also have some very interesting hemispherical differences. So what you're seeing here is a map of the world, and what are the main limiting factors to biodiversity. So in the colder and temperate areas of the northern hemisphere, the main limiting factor is energy. So it's too cold for most species to live there. Whereas if you're looking at tropical areas and the southern temperate areas, the limiting factor is actually water. So it's very important because most of the biodiversity hotspots are actually water limited, not temperature limited. So we need to understand exactly which are the moist environments which we need to protect higher phylogenetic diversity. Like I was saying, most of the basal plants, most of the basal beetle lineages, and likewise with vertebrates, amphibians, for example, of course, they need moist environments. Anyone who's been involved in environmental impact assessment of aquatic freshwater ecosystems would know we have very simple methods to identify biodiversity levels in a river or a stream. This is the example that I'm giving you here is the mini-SAS assessment. So even people who are not trained in taxonomy, they can recognize the broader groups of organisms. So it's very simple to even involve citizen scientists to identify the broader groups. And from there, you can easily calculate phylogenetic diversity, because phylogenetic diversity doesn't always need to know all the species. It only needs to know what the major groups present are. So what I think needs to happen is that we need to understand how phylogenetic diversity varies across moisture gradients from a water body moving away into drier and drier ecosystems. And what I expect we're going to see quite invariably is that phylogenetic diversity peaks at the boundary between terrestrial and freshwater ecosystems. And this is something that I'm working towards to get a group going to actually study this sort of pattern. Like I said, there are these very interesting hemispherical differences. So your typical northern hemisphere landscape with high mountains and broad floodplains is not reflected that well in the southern hemisphere, where you have a lot more high plateaus and deeply dissected valleys. And this will invariably influence the biodiversity gradients in relation to distance to the water. So we need to understand exactly what we are conserving, and we need to understand where biodiversity peaks in relation to these gradients. So that being said, I want to thank my employer, the University of KwaZulu-Natal, the National Research Foundation of South Africa, numerous students and colleagues who have been involved in building on these ideas, and thank you for your time.
We still have about 1 minute. Any questions? No question. So it's good. Only half a minute.
No, that's good.
Okay.
We can move to the next speaker. Would you like me to introduce them?
Yeah.
All right.
Please.
Thanks. All right. Let me just.
Okay, I heard you say that you use environmental impact assessment as in to determine the ecological health of a river or a stream. I want to ask, where do you tell to use a mini SAS or the full SAS5 methodology for you to determine the ecological health of the river?
So this is work that has been traditionally used in freshwater only. Now, my proposition is that it needs to be expanded to terrestrial ecosystems, because that's actually the only way to understand where you get more of these broad groups of organisms in the transition between freshwater and terrestrial ecosystems. So we basically need to map the richness of high taxonomic groups across the entire terrestrial freshwater gradient. You also mentioned estuaries, so of course that brings in marine, and that's an entirely different story. So I'm not going to go in that direction. But we need to understand better the terrestrial freshwater gradient, and unfortunately, this high-level taxonomic identification methodology has not really been applied to terrestrial systems. It's funny that it's only been applied to freshwater. So we need to expand that, because it allows the involvement of citizen scientists. If you want to go to species level, you need taxonomists. If it's good enough to focus on orders and families, then there's a lot of people who can do that. And all of a sudden we can expand the scope of our studies. I hope I've answered your question. Thank you.
Okay, thank you.
Let's continue.
All right. Let me move on by introducing our next speaker. So, our next speaker is Dr. Demelash Adememalede. Is he here? I believe, from the University of Zululand. And he's going to tell us about the interpretation of runoff generation processes in the Buddhico framework.
This one next. Yeah. Okay. Good morning, all. My name is Demelash Ademe. I am a postdoctoral fellow from University of Zululand. My presentation topic is interpretation of runoff generation processes using the Buddhico frameworks. Okay. As we know, the catchment dynamics are affected by different, in the watershed, different land use, land cover, climate, soil, topography variables. So this runoff process is also influenced by water energy dynamics. When we say for water availability, there is precipitation, there is, as we know, there is water balance. Water balance is what we can say for runoff, evaporation, and precipitation. So these interactions are influenced for runoff generation. And also, this runoff generations for nowadays for Budico framework captures these processes by partitioning rainfall processes into runoff and evapotranspiration. It's integrated with SWOT model. You know, SWOT model is a hydrological model that simulates for water balance components. So this topic analyzed or investigates the response of surface runoff and subsurface runoff using these integrated modules. Yeah, the study area name is for Blue River watershed from Ethiopia. The study is located this latitude and longitude, and also it ranges from its high elevation watershed, and also annual rainfall almost 1,300 precipitate millimeters, and also temperature ranges, mean annual temperature ranges about 18 degrees centigrade. And also generally the watershed topographically it's variables. This is the method. As we know, SWOT model uses for spatial and temporal data. When you say for temporal data, there is distillation model, land cover change, and DM, soil data. From this data, we can download from websites from WGS and from the institution, and also the model using for this model to run for water balance components. Integrated with Budico framework, you know, Budico framework characterized for the energy dynamics from the availability of water and the demand of waters like evapotranspirations using this formula. And also result in discussions. As we know, first we should capture for the water balance components for the input of Budico frameworks. That means first we should simulate using the input data and process for the output, and then we can use for the Budico frameworks. Then this is for the calibration, the observed stream flow and simulated flows. Then we should, as we can see from the figure, the stream flow, the observed stream flow, simulated and monthly rainfalls are alignment. That means the model performance is good performing. That's almost 0.7 and above. The statistical variables of night cycle efficiency are square and % of bias. And this is for the results of surface runoff and subsurface runoff for 11 subcatchments. As we can see, there is during the dry season, subsurface runoff is dominated, and during the wet season, surface runoff is dominated. As we can see, from subcatchment 6 have high subsurface runoff. That means it enhances for as we know, if that subcatchment has high subsurface flow, the vegetation, permeable soil, and all these characters have a factor. So among that catchment, subsurface 6 has better subsurface flows. And also this is for the Budico curve. As we can see from this we have 11 subcatchments. From the 11 subcatchments, there is evaporative index and aridity index relationship. As we can see from here, N value, N means catchment parameter or Budico curve parameters. When N value increases, that means that catchment has high infiltration capacity. That means the vegetation cover also very high relative to others. So when we describe this one, if N value is greater That means the maximum greater N value is 1.27 and the minimum one is 0.97. So catchment sub-catchment 6 has better N parameters. This is for the relationship for all the interactions from the catchment, some of the with the slope, the terrain, the permeability, and N value. That means when N, as we can see, if we see for N value, vegetation subcatchment 6 have elevated vegetation, permeability, and slope as we compare for N values. Yes, so this is because in the watershed there is a lot of factors, among that vegetation cover, land use, soil, and permeability affects for the flow of runoff. This is also evaporative index versus runoff. As we can see from here, negative deviation implies evaporative indication is less, then this meaning more runoff. More runoff will take place on that end. Positive deviation showed evaporative index exceeds, that means positive means there is more evapotranspiration takes place in that subcatchments. And also surface runoff is more by rainfall intensity and infiltration excesses. So that, as we can see, subsurface runoff is more evaporative index than surface runoff, because as we know, surface runoff is more quick and more runoffs. And also, many researchers also say, as we can see from here, runoff is more affected by vegetation change, land cover change, and different factors in the watersheds. Conclusion, as we can see from the conclusion, there is, if in dry condition, subsurface flow is high and more, and in wet season, there is more runoff is occurred. And also, as we can say, catchment dynamics is affected by different soil, vegetation, land cover change, and climate. And also, negative deviation means more runoff takes place in each subcatchments. And also, positive deviation, positive if from the Boudica curve, if it is positive deviation, there is more evapotranspiration, more vegetation, and also the soil is permeability. And also, the last, as compared with surface runoff and subsurface runoff, more evapotranspiration takes place on subsurface runoffs. Thank you for your attention. This is my presentation.
Thank you for a very interesting presentation. Any questions? We've got time for 2 questions. Okay, if there are no questions, we can move. We are kind of about 10 minutes behind, so we can try to catch up on a bit of time. Definitely no questions? Okay, thank you. We can invite the next speaker. Thanks so much. Vernon Nagan is here. Just double check. If Vernon Nagan is not here, Vernon Nagan? If not, the next presentation would be Dr. Mkolisi Mukawana is here. So he's going to tell us about an application of the standardized stream flow index for hydrological drought monitoring in the Western Cape province.
Thank you so much, colleagues, for this opportunity to present the research that was done through the Department of Water and Sanitation. My name is Olisim Kawana. I represent a directorate in the department called Water Information Integration. So the directorate has developed a system called the National Integrated Water Information System, which is responsible for disseminating up-to-date and useful water-related information. So one of the dashboards that it uses is a drought status dashboard, which is aimed at generating or disseminating up-to-date drought monitoring and early warning information. So this presentation is just to share with you the recommendations that we have made on how we can turn research into practice and improve the dissemination of drought status information using the National Integrated Water Information System. So this is the outline of the presentation. But as you all know, historically drought have been occurring much more frequently with even more disastrous outcomes. And when you look at the report by international bodies, you can see that worldwide the earth is becoming warmer and drier, and the projections are not giving us anything to look forward to, because as we see from the IPCC that the temperatures are projected to rise. So meaning that drought is more likely to happen and become even more intense. So seeing that we cannot manage drought, but we feel that we can manage the risk related to drought. So the Department of Water and Sanitation decided that we need to enhance our monitoring and early warning by enhancing the currently existing newest drought status dashboard by incorporating standardized drought indices. So currently the system uses the multi-criteria decision analysis, which is not ideal because it assigns weights to the parameters that are being integrated, and that is subjective, and there's no scientific basis in the way the weights are being assigned. And in order to categorize the drought severity, it uses the percentile method, which we also feel is not sufficient to be able to disseminate drought monitoring and early warning information. So that was the motivation behind the use of the standardized drought indices. The central argument here is that there's no single index that can account for the impact of drought on the different water sources as drought propagates from meteorological all the way to hydrological drought. So the SPI, although approved and recommended by the WMO and tested worldwide, we feel that it's not sufficient to give us the direct impact of drought on stream flow, for example, or groundwater. We need, when you use the SPI, you need to establish some kind of a proxy by playing around with the time scale and assume that it represents that particular water source, which we felt is not enough. We need to have an index that can account directly for that particular water source, and in this case is the stream flow. So the issue is that it hasn't been widely tested in South Africa, so we could not really have confidence in the operationalizing of it. Hence this research to test the standardized stream flow index. Because of the spatial variability of the topography and other things in South Africa, we needed to test various probability distribution functions using goodness of fit test to see which one fits the actual data set. And then we also compared, to validate it, we compared it with the SPI and see if it tells us the same language in terms of interpreting the drought scenario. So this is the catchment that we looked at. It's a very important catchment as a water source for the Western Cape water supply system. and the predominant land use there is agriculture. So the requirement for computing standardized stream flow index, which we used the R software, we need a minimum of 30-year record. So the choice of those 3 stations, it was not because we were lazy to use more stations, it's because these are the only stations in that catchment that gave us the minimum requirement in terms of the data record. So you can see that already the spatial representation is not that good. So you will see later on in the recommendations how we plan to deal with such a situation. So these are the equations that we have considered, and we used the Shapiro-Wilk, Kolmogorov-Smirnov, as well as the Anderson-Darling goodness of fit test to see which one fitted the data set best. And we also used the Pearson's correlation test to compare them amongst each other. So the overview of the results, basically the goodness of fit test could not give us any conclusive result, but when we compared this PDF, we saw that the gamma, log normal, and Weibull were able to identify the very severe droughts that occurred around 2015 in the Western Cape, which basically agrees with historical information that we have sent. So based on that, we said, since they are identifying these critical droughts, let us use them. There was no other criteria we could rely on to choose those PDFs. So as you can see, we tested those 5 PDFs for each station, and we found exactly the same results. We could not get any conclusion or conclusive decision based on the goodness of fit test, and then we just used the gamma. So eventually we said, since the SPI, gamma is the commonly preferred PDF, even with the SSI, we'll just use the gamma PDF. So the same applies for the 3rd station that we've used. Those PDFs responded better to the data set than the PT3 and the other ones. So we didn't investigate why. Is it because there are 2 parameter, 3 parameter, and all those things, the mathematical concepts? We didn't look into that because we just wanted to find ways to operationalize. So basically we compared the SSI with the SPI as well, and we find that there was a positive correlation between the SSI and the SPI, implying that they are both identifying the same minor and major drought situations. So that gives us confidence that the SSI is able to characterize drought according to its duration, start, end, frequency, severity, and so on. So these correlations gave us the impression that probably surface water drought is influenced by climate factors because it correlates positively with the SPI. So the conclusion is that, as you saw earlier on, that we had few stations that we could work with, which is not good spatially. So we recommend that we do some propagation studies where we determine which time scale of an SPI correlates best with an SSI1, so that in areas where we do not have a physical station to use, we can use that particular SPI with that particular time scale as a proxy for that area, so that if we don't have a physical station. So that's what we recommend. So the issue of testing PDFs and the issue of not having sufficient station also led us to say that if you are going to apply this method in a different catchment, it would be wise to first test various PDFs. So we couldn't test all other PDFs because of our skills limitation in the use of R software in terms of applying the packages and things like that. But this is, those PDFs that we tested is those ones that we had the skills to test. So what? What are we going to do with all this information? Remember earlier on we said we want to integrate different parameters that represent different water sources so that we can give an overview of the drought status initially currently we're using the multi-criteria decision analysis. And now how can we use the standardized drought indices to integrate these various parameters? This is what we recommend going forward into our research. We need to use copulas to integrate the SPI, SSI, and SGI. So what I presented now is the results that we obtained for the SSI. Tomorrow I'll also be presenting the results on the SGI. So we need to investigate how we can combine the four indices. The SPI 1 to 3 months, it will help us to identify drought early as it occurs. And then the SPI 6, it will serve as a proxy for agricultural drought because we don't want to use the VCI for obvious purposes. Areas that are built, we don't have a good picture of the vegetation health. And then the SSI 1, as we have demonstrated now, as well as you will see later on in my presentation, we also have some results, some good results on the SGI. So that is how we want to enhance the newest drought status dashboard using standardized drought indices. So the whole project, I've condensed it into a poster. So if you visit the poster room, we can discuss more about it, and maybe we can share some ideas on how we can better implement the standardized drought in this approach. Thank you for your time.
Thank you, Dr. Mukawana. Nice geographic area to be working in the Berg River. In fact, if I remember correctly, when the Dutch first arrived, before Cape Town existed, they were more interested in Saldanha, but because it made a better natural harbor, but it wasn't close enough to Berg River mouth, so there wasn't enough water for them, and that's how Cape Town ended up where it is. Questions from the audience, please. We've got time for 2 questions. There's a question over there.
Thank you very much for your presentation. The drought indices are basically driven by the availability of data. So precipitation data, the SPI, is by far the easiest to deal with. Why did the department select an approach where we need to use with data sets that's not easily available as opposed to precipitation data that's a lot longer records available?
Thank you for that question. It's a very valid question. Yeah, from where you are sitting, it appears that rainfall data is very easy to find. But believe me, we also have to buy rainfall data from South African Weather Services. So we have to buy it as well. And I know many people will be surprised by that, but that's how it is. So we have tested CHIPS data to see how it compares with the in-situ data from South African Weather Services. So we discovered that the pixel to point comparison or correlation is not so good at around 80 to 85%. But when we compare the aggregated rainfall district for CHIPS as well as the in-situ data, the correlation improved to around 95%. So we decided that because we are looking at drought and it's insidious and it's widespread, as opposed to floods, for example, which are localized and they can happen instantly, so we don't really need that absolute accuracy. And it being widespread, we can use the rainfall districts that were established by South African Weather Service to replace the in-situ data. So we do continue to use the SPI as you can see in here. Okay, it's gone. As you can see in the integrated version, the non-linear multi-index approach, We still want to use the SPI 1 and 6, but not relying on the in situ data sets because for that obvious reason. So, but we did an assessment to compare chips and in situ, find that at the district level, which is a much more bigger space, the performance is much well. Stream flow data is not difficult for us. We own the data. We should have the data. It shouldn't be a problem in a perfect world, but maintaining stream flow gauging stations is very, very expensive. When it's washed away, to rebuild can cost about 60 million rand. Vandalism, people when they say shiny something, they just want to take it and hang it in their room, hoping that one day they will sell it. So it's so challenging. So yeah, we cannot have data that covers the whole country the way we should have. So I know we should have rainfall, we should have stream flow, but we're also looking at digitalization technologies, virtual weighers, to see how we can supplement and complement the existing in situ network. So there is other things we're looking at, but yeah, the situation is the way it is.
Thank you, Dr. Mukawana. In the meantime, we've run out of time. Just double checking, is the previous speaker, Vernon Nagan, is he here? If not, I will ask Professor Hui to introduce our next speaker.
So the next speaker is Feng Yudong. He is from Nanjing Soil Institute of Soil Research Institute, Chinese Academy. His topic is detection of microplastics in human blood through baths based on Raman spectroscopy. Please.
Good morning. I'm very pleased to be here in beautiful Durban for this conference. I'm from Institute of Soil Science, Chinese Academy of Sciences. Today, my presentation, the title is Detection of Microplastics in Human Blood Thrombus based on Raman spectra. My presentation will be divided 4 parts. Part 1 is the research background. As we all know, we will use plastic every day. Plastic is difficult to graduate or graduate in the environment. So they will rely in the environment a very long time, but they can break down into pieces of smaller pieces like microplastics. Microplastics are significant solid particles or polymeric materials with a regular or irregular shape and with size ranging from 1 micrometer to 5 millimeter. It is reported approximately 37 million tons of plastics waste had been generated, around 9% which had been recycled, and 79% was accumulated in landfills or the natural environment. Therefore, so daily water drink performance tubers. But there is no significantly with the number of particles detected in the thrombus. However, we have found a significant positive correlation with the indicator between number of particles in brown thrombus and platelet levels. It is may indicate that microplastics or the particles will affect the blood thrombus formation. In summary, in these studies, we provide the first detailed photographic and spectral evidence of particle accumulation in brown thrombus. A large number of particles from significant materials such as dyes and plastics were detected in brown thrombus. The particles were block-shaped, ranging in size from 2.1 to 26 micrometer, with 69% of particles smaller than 10 micrometers. So part 4 is outlook and acknowledgements. In the future, we should more focus on nanoplastics. We should know how can nanoplastics in human tissue be detected. How can micro or nanoplastics be observed in human tissues? And what role do micro nanoplastics play in process of broader thrombus formation in human? That's all. Thank you. Thank you very much.
So, any questions?
Thank you for your very interesting presentations. My question is that, are there any other methods for detecting the microplastics, especially in the environment? Thank you.
Oh, thank you. Thank you for your question. There are also other methods for detect microplastics. In this study, we use Raman spectroscopy. But you can also use the FTIR or PYGS mass for detect microplastics. But if you want to detect nanoplastics, it's more difficult. Now have not a good method to detect. Thank you.
Okay, questions? Yeah, I have a question. Can you, do you have data about the microplastics do to the health of the human beings?
I know, as now, there are no direct evidence for human health is affected by the microplastic. There have no sound evidence, so we need to research in deep to make sure that microplastics will affect the human health.
Okay.
Thank you.
Questions?
I want to ask more further on the causes of microplastic inside human bloodstream, or what exactly gets the microplastic in human's blood.
Sorry.
If you have researched about that, the main cause of the microplastic in human blood.
Blood. Sorry, your question is I don't understand.
Okay, my question is, I don't know if I got you right. If you have detected microplastic in human blood, what is the cause?
This is so we will eat food, drink water.
Okay.
This food and water have contains microplastics or nanoplastics.
Okay.
So we will or you will inhalation or ingestion. This way also will can the microplastics will transfer into the blood. So when the microplastic particles in the blood, they will reach the other organs.
Okay, thank you.
Thank you.
Okay, so I think perhaps it's break time. So yeah, it's 11:13. 20 minutes or 11:30. 11:30 will be.